want to review a little bit before I go into any new material. And if you have any questions about any particular problems, just email me, send me a picture, whatever, and I'll help you that way. I usually just work them out and send you a picture back. Okay, but geometry, of course, means earth measurement. Euclid was the main geometer that we will study, and we study Euclidean geometry. He wrote a book called The Elements. We had 3 undefined terms, point, line, and plane. They were so basic he didn't even start out with definitions, and then everything else in geometry has a definition to it, and you need to memorize those. And it's kind of hard because we're covering a whole book of geometry in 2 lessons. Okay, we have angles, okay, which like angle A, B, C, or angle CBA, angle B, or angle 1. So you can name that angle in 4 different ways. B is the vertex, where the 2 rays come together. We have different types of angles: acute, right, obtuse, okay, and straight. A straight angle is equal to 180 degrees. Okay. Acute is a small angle. We had problems that we had to solve that they would say these are complementary angles. If the measure is of 1 is 30, how much is x? Complementary means it equals 90. So x plus 30 equals 90. So x is 60. Okay, I usually just subtract 30 from 90 and get 60 to get my answer. I always double check, make sure that those add up to 90 degrees. Okay, if they are supplementary, then that means it's 2 angles that add up to 180. So if this is 30, and you need to know the measure of that one, 30 from 180 is 150. Check to make sure it adds up to 180. Okay. Next, we had 2 lines cut by a transversal. These lines are parallel, and this is the transversal. If we know one angle, we can find all the rest of them from different things that we have studied and memorized. So if this is 30 because these are vertical angles. If this one is 30, then this one is 30 because they are alternate interior angles. If this is a straight line and this is 30, then that one is 150. And so that's 150, that one's 150, that's 150, and that one is 30 over there. So you just match up all the angles. And I always redraw my problems because when they put little 1, 2, 3, 4, 5, 6, 7, 8 in there, it messes you up. Okay. So we did those problems out of the book on those. Alright, the next thing we had was 9-2, which is different polygons. And we talked about the names of different polygons. And this is on, let's see, page 485, this chart right here. And you have triangles, quadrilaterals, pentagons, hexagons, heptagon, octagon, nonagon, decagon, dodecagon, and a cosagon. Okay, and then we talked about that you can figure out the measure of the interior angles of any shape, okay, by dividing it up into triangles. You can divide it like this, and you've got 4 triangles, so that's 4 times 180, or 720 degrees, for the measure of all of the interior angles. This plus this plus this plus this plus this. Now, this can be a shape like this, where they're not all equal to each other. Okay, but this one, all those added up, still add up to 720. These do not have to be regular polygons. for them to be the same. We learned that there is a formula. If you take the number of sides minus 2 times 180, then it will add up. You will find out the measure of the interior angle. So this is 1, 2, 3, 4, 5, 6 sided. So 6 minus 2, or 4 times 180 gives you 720. So you can draw it, or you can use the formula to figure out the measure of the sum of the interior angles. Also, if these are interior angles, then this would be an exterior angle right here. So if it is a regular polygon, okay, and all the sides are equal and all the angles are equal, like that. If it's equal to 720 and you have 1, 2, 3, 4, 5, 6, 6 will go into 720. Okay, so each one of those angles is 120. So then the exterior angle, that one right in there, if they wanted to find that out, it would be 120 from 180, or it would give you a 60 for the exterior angle. Okay, so the exterior angles, are all around this thing. But a lot of times they want to know what is the measure of an exterior angle. Then the chart on 487 has, you can classify triangles according to their angles. You have an acute, an obtuse, and a right triangle. You can classify triangles according to their sides. Isosceles, 2 sides are the same, and those bottom angles will be the same. Equilateral, 3 equal sides, 3 equal angles. And then scalene, no 2 sides are the same. Okay, so be very careful on this, because if you're classifying the triangles according to their angles, that's the way you have to answer the question. Okay. Now, next we had similar figures, which meant that the angles are the same and the sides are in proportion. Okay. So this angle would be the same as that one, that the same as that, this one the same as this. And they are similar, which means they're the same shape but different sizes. Excuse me. Okay, and we learned to set up a proportion to work these problems. And you match up the sides that go together. You always look for the 2 sides that both have numbers on them before you can work the problem. Okay. If you had something like this was 5, this is 10, and this is 8, and over here we had a 2 and an X, and you wanted to find X. Always find the 2 sides that correspond, that both have numbers. So 5 is to 2 as 10 is to X, like that. Then if you wanted to find this one, you would still say 5 is to 2 as 8 is to Y. Okay. Next thing we had were special quadrilaterals. Okay, quadrilateral is a 4-sided figure. So a quadrilateral, the definition is it has 4 sides. Everything underneath takes on the qualities of the thing above it. So if it's a parallelogram, it is also a quadrilateral, has 4 sides. Definition of parallelogram, opposite sides are parallel. Down beneath it, you have a rectangle over here. So opposite sides are parallel, but the definition of a rectangle is 4 right angles. Over here, we have a rhombus. Definition of a rhombus, it is a parallelogram, opposite sides are parallel. And what makes it a rhombus is it has 4 equal sides. So if you take the properties of both of those, a square has 4 right angles and 4 equal sides. Now, a square is also a quadrilateral. A square is a parallelogram. Anything down under here is the same as what's above it. A trapezoid is a quadrilateral, it's a 4-sided figure in which 2 of the sides are parallel. Okay? A special trapezoid is a isosceles trapezoid where 2 sides are the same. Okay, now the isosceles trapezoid, it is a trapezoid and it's also a quadrilateral. But these two are not the same. The only thing they have in common is that they're quadrilaterals. Okay. Then you had problems with dealing with all of these. Okay. Now, let's see. I looked at some and show you like 29. We looked at this a little bit, where redraw your picture and get out the things in there that mess you up. Okay, but on 29, if it started out with this one was 25, so that one would be 25 because they're vertical angles. And this is 138, and that one's 138, so they're vertical angles. And so you had to add these two together and then subtract it from 180, and then that's how you got the 17. 31, these were vertical. Okay. Let's see. This was 57, so 57 from 180 is 123. So you had 27 and 123, add them together, subtract from 180, and you got 30. But what they wanted was the measure of this exterior angle over here. So that's a straight line. So 30 from 180 gives you 150. Down here, okay, you have parallel lines, and you've got a triangle in here, but you can also look for transversals. Okay, so on this one, all they gave you was this was 63 and this was 67. So I always take out all the numbers, and then 63 and 67 add together, subtract from 180 will give you this one over here. Then you can get all the rest of them. These are vertical, and so they're equal. That's a straight line, so 50 from 180 is 130. And then over here, same thing. These are vertical. There's your straight line, so 67 from 180 is 113. Then over here, these are vertical, okay? All right, over this one, you've got parallel lines and a transversal, so that's 50, then that's 50. And then if you have 50 and 63, add those together, subtract from 180, and you get 67. And then those are the same because they're vertical, and these are the same, and those are the same. Okay. All right, another one on 41, we had to find an XA, determine the measure of an interior angle of the regular polygon. Regular means the three sides are the same, the three angles are the same. So you have to know what regular means. Now in 41, it was a triangle. So if the sum of the measures of a triangle is 180, then 180 divided by 3 gives you 60 for each angle. Okay. Then they want to know the measure of this exterior angle right here. So 60 from 180 gives you 120. On 43, it was a regular octagon. And so I put that all the angles were the same and all the sides were the same. Now it said you figure out that it's 8 minus 2 or 6 times 180 or 1,080 degrees for all of these added together. But then you want to know one of them, so you divide it by 8. So that gives you 135 here. They want to know the exterior angle, so that's a straight line. So 180 minus 135 gives you that angle. Okay, a 12-sided figure. I did 12 minus 2 times 180, and that's 10, or you end up with 1,800 degrees. To find one angle, divide it by 12, because it's a 12-sided figure. So one angle is 150. So if on the inside of this particular shape is 150, then you have a straight line. So 150 from 180 gives you 30 for the exterior angle right there that you want. Okay. All right, the next one, number 47. If you on 47, you have to match up the sides. these two have numbers on them, so 10 is to 4. If you want to find x, x is to 2.4. Cross multiply, this times this, and that times that. So that's a 24, and that's a 4x, so x is 6. Okay, over here, you want to find y. You still use the same two numbers that matched up. So 10 is to 4 as 8 is to y. Cross multiply, you get that one. The answers are in the back. 49. On 49, they have them in the right order, which is good. So you didn't have to redraw. Find the two sides that have numbers. 4 is to 10 as x is to 6. Cross multiply, 24 equals 10x, then divide 2.4. And then this one, find y. 4 is to 10, and then 3 is to y. So 4y equals 30, and you divide. 51. Okay, 51, they're in the same order, so that's good. These two have numbers, so 2 is to 1.25 as x is 2.75. Cross multiply, you use your calculator, get that. Same thing on the y. 2 is to 1.25 as 1 is to y, because that's what it corresponds to. Okay, 53. Okay, on this one, we had to take it apart because it was like this, and you can't figure it out, but they're similar. So if you pull this one out and put it over here and label it the same way, it said ABC. ABC is similar to DEC. So that's how I knew where to put the letters. Okay, and then the 6 goes here, the 10 is the long one. Over here, there's the 2, and then that's 2 there. Now, first thing you had to find on this one was find side BC, or you want to find that one right there. Okay, so find the ones that have the numbers. 6 is to 2 as this, wait a minute, is BC, oops, oh, here it is over here. This was the next one. Okay, 6 is to 2 as BC is to 2. So that's 12 equals 2 times x, or whatever. And so it comes out to be a 6. Okay, and then on 55, you've got to find the length of this one first before you can even work this problem. Okay, so 6 is to 2 as 10 is to this one over here. So that's 6. You can call that 6DC, or you can make it a y or something like that, equals 20. And then you divide, find out what it's equal to, and then once you get it, you have to subtract it, because you've got to put it back in the problem. They wanted to know, on 55, find side AD. They wanted to know this distance here. So once you found this distance, then you subtract it from 10. That'll get it. If anyone needs more information, let me know. Okay, on 57, okay, these were not drawn the right way, so I flipped it around, made ABC, made A prime, B prime, C prime, filled in all the information, and they're congruent, so that helps you a whole lot, because if this one's 14, that'll be 14. If this one's 30, that'll be 30. If this is 84, that'll be 84. If this is 28, that'll be 28. And so forth and so on. On 59, the length of AC, it was also 28. Okay. Then on 63, okay, I flipped that one over and put them beside each other, and they're congruent. So if this is 70, that'll be 70 over there. If this one is 50, then that'll be 50 over here, so forth and so on. Now, how could I find out the measure of that angle right there? Okay. All right, this is a quadrilateral, so the interior is 360. Say 2 times, each triangle. If you divide it like that, 2 triangles, 180. And then I could add those up, subtract from 360, and get that one if I wanted it. Okay, on 73, we did this one. So you set it up, x is to 6 as 105 is to 9. I believe it is, or maybe 91. Let me look. Yes, to 9. And so that's 9x equals, let's see. Okay, 630, and then divide and get your answer on that. So this one you had to take them apart, okay, in order to work it. 79, these were in the right order, okay, but 5.5 goes with x as 2.5 goes with 20. Cross multiply, and you'll get your answer on that one. Okay, but if you need any more explanation, just let me know. Okay, now the next section, which was 9.3, we did perimeter and area. Perimeter is distance around, area is what's inside. Now, if you did this first, it's actually the easiest one to do. And so you had to find the perimeter of these. So you add 7 and 7 is 14, 5 and 5 is 10, and 10 and 14 is 24. These you just add all those up, and these you add those up. Perimeter is easy. Okay, number 4, find the perimeter of a rectangle whose length is 12 and whose width is 7. Okay, so draw these figures. Okay, it's 7 and 12, and that's 7 and 12 because it's a rectangle. Opposite sides are equal in a rectangle. So 12 and 12 is 24 plus 14, and you get your answer. Find the perimeter of a square whose side is 5.5. So if you draw that one, 5.5, 5.5, 5.5, 5.5. Okay, so you have 5, 10, 15, 20. Okay, and then, so, or you can also say, on this one, the perimeter is 4 times this, and that will get your answer on it. And I'll give you the answers when you come back. Okay, find the area and perimeter of a certain square. Area and perimeter of a certain square are the same length. So the perimeter and the area are going to be the same number. So you've got to find the length of one of the sides of the square. So what you got to do here is just try numbers. Try like 1. The perimeter would be 4. The area would just be 1. So that didn't work. Try 2. Okay. The perimeter, 2, 4, 6, 8. The area, 2 times 2 is 4. That didn't work. So try another one till you find one that works. Okay, the next one, number 7. The area of a rectangle is 24 square inches. And the length is 8. Find the width. Okay. Formula for area is length times the width. Okay. So if the area is 24, the length is 8, and the width, then you just have an equation that you can work out very easily. Okay. Just draw pictures and fill it in. Okay. Let's see. Find the area of a parallelogram. Okay. Whose base is 14 and whose height is 8. Okay. So if you look at your formulas on the bottom of page, let's see, 498, the area is base times the height. Okay, so number 8, base times height. So you just have to put in 8 times 14 and you have your answer. Okay, on number 9, we have find the area of a triangle whose base is 13 and whose height is 7. Okay, here's the base is 13 and height is 7. Area of a triangle is 1/2 of the base times the height. So all you have to do is put the numbers in and you get your answer. Okay, find the area of a trapezoid. So we've got a trapezoid. Okay, bases are 10 and 20. So I'm going to put 10 here and 20 there. Height is 6. Okay, formula, area of trapezoid, 1/2 of the height times base 1 plus base 2. Doesn't matter which one is 1 and 2. The height is 6. I changed that to brackets so it won't get mixed up. But it doesn't matter. Okay, 10 plus 20. So you've got 1/2 of 6 and then 30, and then multiply that out and you get the answer. Find the circumference and the area of a circle whose radius is 7. Okay, circumference is pi times d, or it can use 2 pi r. Okay, so I'm just going to use d. If this is 7, that's 7, then the diameter is 14, so I'm going to put 14 pi. Okay, the area is pi r squared. Alright, so pi times the radius is 7 squared, or 49 pi. Okay, so these are a little bit simpler than the ones that are in the book. Okay, so you may want to do it first. Alright, then 9.3, we did more on Pythagorean theorem and things like that. Okay. Alright, now let's look at, let's see, did you have a 9.3? You did 5 through 27 odds, and 41, 51, and 53. Okay. Alright, one that you might want to see is number 25. Okay. Okay, on this one, you have, it's kind of hard, but you need a plan. Okay, you've got to find the shaded area. Okay, now it looks like on this one that you don't know anything. Okay, because in order to find the shaded area, this is a square. Okay, and you need to know the length of a side. You don't know that. Okay, so you have to think, okay, if this is 4, this is halfway in there. Okay, so that's like a 2 right there. Alright, and same thing down here. So, if I could figure out the hypotenuse of that triangle right there, that would be the length of the side. So I would use a squared plus b squared equals c squared. So 2 squared plus 2 squared equals c squared. You're trying to find c right there. Okay, solve that equation and you'll have the length of that side, and you can multiply it times itself, and that will give you the answer. Okay, on 27, you've got a trapezoid. Okay, and you have a circle in here. I didn't draw it exactly right. Okay, this is 4 inches, and this is 20, and this is 9. Okay, now, to get the area of a trapezoid, it's 1/2 of the height times base 1 plus base 2. Okay, now, alright, so what you've got, base 1 and base 2, 9 plus 20 on this one. Alright, you've got to, in order to get the shaded part, your plan is area of the trapezoid, which is upside down, minus the area of the square. Okay, I mean the circle. And then that should give you what's left. If you take that out, it'll give you what's left. Now, the circle we can do pi r squared, so pi times the radius 4 squared, or 16 pi. So you got part of it. Now what you need is the trapezoid, which we worked part of that. Okay, we need the height. Okay, we don't know what that is. But if you take this radius and turn it around up here, that's also 4 inches, and this part's also 4 inches. So the height is 8. Then you can work that out and get the answer. It should be in the back. Okay, all right, now 51 is just using the Pythagorean theorem. It's just like that. And you've got 52 and you've got 90. So, I mean, it's not the Pythagorean theorem. It's, oh yeah, it is too. Okay, so you're trying to find that right there. So use the Pythagorean theorem and you can get it. Okay, 53 is the same way. Okay, you see how that makes a right triangle? This is 9 and this is 41, and you're trying to find that side right there. Alright, you've got a squared plus b squared equals c squared. But notice on this one, c squared is here. Doesn't matter on a and b, so 9 squared plus b squared. And then solve that, and you'll have your answer. Because on the Pythagorean theorem, the hypotenuse must go in the place of c squared before you can figure that out. Let's see. Alright. Okay, next on the volume. Okay. The main thing on the volume is figuring out your shapes. Okay. And if you have a rectangular solid, okay, which is something like this. Okay, and you're trying to find the volume of it. A cylinder is like this. Okay, a cone is this particular shape. What's that? Okay, a sphere is like this. Okay, so you just look at your formulas and fill them in. And so you have different problems related to these. Okay. The only one that might give you any problem at all is the sphere, which is 4/3 pi r cubed. Okay, but you can use your Y the X button on your calculator and figure out what that is. If this is a 3, then you do 4/3 pi 3 cubed. Okay, and 3 cubed is 27. So 4/3 pi times 27. Okay, now you can go through on 27 9 times. 9 times 4 is 36 pi. You can leave it like that, or you can multiply 36 times 3.14 button on your calculator. Okay, now the next thing are prisms. Okay, prism, we're not going to do the part on Euler's polyhedron formula, so don't even look at that. But the volume of a prism we are doing. Okay, so the volume of a prism is the area of the base times the height. Okay, so if you have a particular shape, like a triangle at the bottom, okay, then you'll have a triangle at the top also, like that. So you would just have to get the area of this base and then multiply it times whatever the height is. Okay, and then you have to go back to the previous section to get the formula for the area of a triangle. So you get the triangle and then whatever the height is, they'll give that to you. Then pyramids they're like different shapes. You might have a square at the bottom. You might have a triangle at the bottom. You might have a hexagon at the bottom. Okay, it doesn't matter. You have to get 1/3 of the area of the base times the height for a pyramid. Okay, so the area of the base, this one's a square, so you'd have to have numbers there. This one, you'd have to get the area of the triangle, then multiply it times height, and then take 1/3 of it. Same thing over here. And I'll tell you how to do it. Okay, let's look. Let's see, 9% to 21. Right. Let's look at, this is 9/4, and you had 7 through 21 odds, and number 43. Okay, so we'll just do 1 or 2 of those and see if we get them right. Okay, so if you do number 9, okay, find the volume of this. This is a cylinder, so you have to go back and find the formula on this page over here, 508, for the volume of a cylinder. That's why on your final, I'm going to let you use your book and your notes, because you've got a whole lot of formulas and stuff, okay, to do. But anyway, so it's pi r squared h. The volume is pi r squared h for the volume of a cylinder. So on number 9, okay, it's like this. And this is 2 inches. And this is 1 foot. Okay, I would change this into 12 inches because you always have to have them the same. Okay, so pi times the radius, which is 2 squared, times the height, which is 12. So that's 4 times 12. Okay, so 48 pi will be your answer on that one. Okay, number 13 is probably the hardest one that you had to do because it looks terrible. Okay, but what it is a trapezoid on the bottom, okay, like this, and a trapezoid on the top, okay, and then you had them connected, kind of. Okay, so you can look at this because it's kind of hard to draw on here. But anyway, this is 8, so base 1 is 8, base 2 is 12, and the height of that trapezoid is a 10. Okay, and then this part right here is 24 inches. Now, so that is like a prism, and so it's the volume is equal to the area of the base times the height. Okay, the bases are trapezoids, so you have to go back to the previous section. 1/2 of the base, 1/2 of the height times base 1 plus base 2. 1/2 of the height times base 1 plus base 2. Okay, so 1/2 of the height is 10, times base 1 plus base 2, 8 plus 12. Then all of this is your base. Then you do the height, which is 24. So half of 10 is 5. Is that 20? Okay. So that's like 100. I think. Oops. Okay. And then times 24. So this is the base right here, which is your trapezoid. Get the area of the base and then times the height. Okay. Whatever units of cubed. Okay, and then 21. On 21, get your have a plan, which is to take your rectangular solid, okay, minus your cylinder. Okay, so you want the rectangular solid minus the cylinder, and you should be able to do that. Okay, and the cylinder has that this is 2 meters across, so the radius would be a 1. Okay, the height of the cylinder is the same as the length of the side over here, which is a 4. So you should be able to work that one, and I'll work it for you when we get back if you didn't get it. Okay. Now, okay, I think that's basically a review of Chapter 9. Next thing we're going to do is look at Chapter 11. All we're going to do on this is working percent problems by changing them to equations. And we've already had equations before, so it shouldn't be hard to do. You look at your keywords like is, of, and things like that. So the first one is 10 is equals what percent x of times 12. You just write an equation and you can get the answer. 10 is what percent of 12. So this gives you a 12x. So you would divide through by 12. Use your calculator, 10 divided by 12, and get it as a percent. So just fill these out. Just change each one. What number x is equals 3% times 8. 7 equals 0.10 times x. What percent x times 108 equals 27? What percent x times 60 equals 42? Okay, so I just wanted to make sure that we went over that to help you in that part. Now the next thing that we're going to do, if I can find my notes, is probability. Probability is on Chapter 12, and probability is a guess expressed as a fraction. This part will not be as hard as the last part was, hopefully. Okay. Now, it can be written as a fraction, or it can be written as a ratio, like 1/2 or 1:2. And it's a guess expressed as a fraction. Okay. Now, the formula for probability is the success over the total. P equals S over T. Success over total. What you want to occur versus what could occur. I wish I could make this bigger for you. I just don't know why it's not working today. Anyway, so the success is what you want to occur. The total is what could occur. Now, the first one, we're just going to work problems with this and you'll get the hang of it. Find the probability of rolling a 2 on a die. Okay, a die is one piece of dice, okay, and it has 6 faces on it with numbers 1 through 6, like this. 1, 2, 3, 4, 5, 6. Now, what you want to occur is you want to roll a 2. There's one of those. There's only 1, 2. Out of all the other ones, there's 6 different choices. So the probability, if you threw a die, you would get one chance out of 6 throws that you would get, a die. So that's the probability of rolling a 2. The second one is find the probability of rolling a 5. Okay, how many 5s are on the die? 1. There's only 1 5, and there are 6 possible answers. So, 1 out of 6. Find the probability of rolling an even number. Now think about the die. Okay, how many even numbers do you have? 2 and 4 and 6. So you've got 3 that might be even. So what you want to occur is to get an even number. There are 3 of those. What could occur is there are 6 choices. So it's 3 out of 6, reduce it to 1 over 2. So your chances or probability of rolling an even number is half. Always reduce them. Number 4, this is a little bit different type. Find the probability of it raining on the weekend. Find the probability of it raining on the weekend. Okay? The weekend has 2 days, Saturday and Sunday. Okay? So what you want to occur is for it to happen on the weekend, so that's 2. It could happen on any out of 7 days. So the probability of it raining on a weekend day is 2 out of 7 total days in the week. Okay, so I hope this makes sense to you. Probability is a success, what you want to occur, over the total, which is what could occur. Okay, now, find the probability of rolling an odd number. Okay, think about the odd numbers on a die. 1, 3, and 5. So, success, there's 3 of them out of the total 6. Okay, so here's the odd ones. There's 3 of those out of the total 6. Reduce it 1/2. Next, find the probability of it raining on a weekday. Okay, there are 5 days, 1, 2, 3, 4, 5, that are weekdays out of the total 7. Okay. Next thing we're going to do is cards. Now, some people are familiar with cards, others are not. Okay, there are 4 different suits in a deck of cards. You have diamonds, hearts, clubs, and spades. Okay, there are 52 total, so that means there's 13 cards in each suit. There are 13 diamonds, 13 hearts, 13 clubs, and 13 spades. Okay, find the probability of drawing a diamond from a deck of cards. Okay, how many diamonds are there? 13. 13 diamonds out of the total number 52 cards. So, the probability, success over the total. 13 diamonds out of 52 total cards. Reduce it 1/4. That makes sense, doesn't it? Okay, there's 4 different suits, so you got 1/4 of the chances that you're going to draw what you want. Find the probability of drawing a queen. Okay, now let's think about that. We got a queen of hearts, a queen of diamonds, queen of clubs, and queen of spades. So there's only 4 of them out of a total of 52 cards. So 4 queens, that's what you want to get as a queen. What you could get is, or the total is 52 cards. So reduce it 1 out of 13. Find the probability of drawing a 7 of hearts. Okay, how many 7 hearts do you have? Okay, only 1. So here's hearts. So 1, 7 of hearts in the whole deck. So 1 out of 52 is your answer on that one. Okay. Now these are a little bit harder, but not much. Find the probability of not throwing a 2 on a dice. Okay, all you have to do on this is figure out how many are not 2s. There are 5 of them that are not 2s. So the probability that they're not 2s is 5 out of 6. Find the probability of not drawing an ace. There are 4 aces in the deck. How many are not aces? Okay, 48. So the probability of not drawing an ace is 48 out of 52. So that's 12 out of 13. Okay. Now, let's see. All right, next thing we have odds. People always say this. I say, I wonder what the odds of doing blah, blah, blah is. Okay, the odds is the success over the failures. Okay, now, what are the odds in favor of rolling a 2? Okay, and you think about the dice. There's 1, 2 on there. Okay, so you want a 2, so there's 1. Okay, how many are not 2s? There's 5 of them that are not 2s. So the probability in favor of rolling a 2, success, we want a 2, there's 1, 2. How many of them are not 2s? 5 of them. So 1 out of 5 are your odds of rolling a 2. What are the odds in favor of rolling an even number? Okay. Odds in favor of rolling an even number. Success over failure. Okay. How many even numbers? 3. How many are not even? 3. So your odds is 1 to 1 that you're going to roll an even number. Odds are kind of strange. What are the odds in favor of drawing a heart? Okay. Success, you want a heart. How many hearts are there? 13. How many are not hearts? 52 minus 13 are 39. So there are 13 that are hearts, 39 that are not. Reduce it a third. What are the odds against rolling a 2? Odds against is the failure over the success. Or in other words, it's a reciprocal. Okay? So the failures, there are 5 that are not 2s. The successes, there's only 1. So the odds against is 5 out of over 1. Okay? It's a reciprocal of number 1 up here. Okay. I wish this was clearer, but I just can't make it any bigger for some reason today. Okay. Now, we have another thing. Alright, this is if you, I suppose you have a stadium and you've got 4 gates on this side, A, B, C, and D. And you've got 5 gates to go in and out of over here. Okay. And some people sit around and think of these crazy things, and they'll say, how many ways can you go in one gate and out another gate? So you could go in gate A and out E, in A and out F, and so forth and so on, like this. Alright? Or you could go in B and out that one, like this. Or in C and out that one, in D and out those. Okay, so what you really have here are 4 ways to go in, 5 ways to go out. So you got 20 different ways that you can get out. Okay, another thing we have is a lot of times you have something like you want to see how many different ways you can make up a meal. We're going to say that we have bacon and sausage for breakfast. We have scrambled eggs. We have fried eggs. And then we have apple juice, orange juice, and tomato juice. And we want to figure out what is the probability that you had a scrambled egg, sausage, and orange juice. Find the probability you had a scrambled egg, sausage, and orange juice for breakfast. Okay, so what we have to do is do a tree diagram. Okay, we divide it into bacon and sausage. Okay, those are our meats. Then if you have bacon, you might have scrambled or fried eggs. If you had sausage, you might have scrambled or fried eggs. Then you might have apple, orange, and tomato. Apple, orange, and tomato. Apple, orange, and tomato. Over here. Now, the probability that you had a scrambled egg, okay, sausage, okay, here's a sausage one, okay, a scrambled egg, and orange juice. It's like this one, and this one. Okay, so if the probability is success over the total, you've got one way that you could have sausage, scrambled, and orange juice. Out of the total, 3, 6, 9, 12 different ways. Okay. Now, another thing you might say, what is the probability that you had bacon for breakfast? What is the probability that you had bacon? Okay, here's bacon, there's sausage. Success, or half of them, you've got 6 out of the whole thing, 12, or half the chances that probability that you would have bacon for breakfast out of those choices. Okay. Now, the next thing, and this is last, is permutation. Okay, a permutation is a particular ordering of the elements of a given set. A particular ordering of the elements of a given set. And we're going to talk about factorial. You'll have this something that looks like that. Okay, 4 factorial means 4 times 3 times 2 times 1. And that would get you your answer. 4 times 3 is 12. 12 times 2 is 24. Times 1 is 24. If you had a 3 factorial, that means 3 times 2 times 1. So that's a 6. Okay, there is a key, if I can find it, on, let me try it, see if this will work right here. On mine, there's a little X with an exclamation point on it. So we'll see if that works. 4 second factorial is 24. So it does work on mine. But it's right here. X factorial is what the key looks like. You've got a 3 second factorial is 6. Okay. Now, you can also have something like this. 5 factorial over 3 factorial. 5 factorial means 5 times 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1. Okay, those cancel, so it's just 5 times 4, 20. Now, you can try it on your calculator and see if that works. okay, and it does on mine, you would key in 5 second factorial button divided by 3 second factorial button. Now I think you have to do an equals. Let's see, 5 second factorial divided by 3 second factorial equals 20. Yeah, and you have to put the equals in there. Okay. There's all sorts of other things you can do with this, but we're not going to get into it. Okay, now we have one worksheet on the probability, and that's all that we have. Okay, it looks like this. Okay, now this will be worked the same way, but we have different types of problems. Okay, a bag of M&Ms usually contains 20 pieces of candy. I left out the color green, so I wrote it up here. Pamela purchased a bag that contains 7 orange pieces, 4 yellow pieces, and 3 red pieces. Pam selects 1 piece of candy from the bag at random. Find the probability that she will select one of these things. So, what you want is a red piece. Okay. Alright, so the probability equals the success over the total. Alright, the success is what you want, so you want a red piece. Alright, there are 3 red pieces. Okay, the total, there are 20 pieces. Okay, so you've got 7, 11, 12, 14, and then 6 green. Don't forget the green up here. Okay. Alright, so that would be your answer on the A part. Alright, next one, a green piece of candy. So you do it the same way. Then you've got a red or a yellow. Now I'm not going to tell you how to do the or and the nor on here, and I'm just going to see how it comes out. But all that you will be required to know, like on the test, will be a straight problem like number 1. Okay, or on die or on cards, and you won't have to do the or and the nor, but I'm just leaving that in there just in case. And here's gumdrops, same type of problems. Down here you got die and the probability of rolling a 4, a number less than 4. Okay, let's suppose you had to do that one, which you will. Okay, now your probability is the success over the total. A number less than 4, okay, that would be 3, 2, and 1, right? So there'd be 3 of those over the total, which is 6. Okay, so the probability that you would roll a number less than 4 would be 1/2. Okay, now, so that's all that you have to do on chapter 12. Okay, now, we will be back, I think, on December the 5th. Okay, so I'll be back on December the 5th. So you have until then to get all the work done, but you'll want to do it while you still remember how to do part of it, because if you wait until the day before that, you won't remember how to do any of it, unless you go back and listen again. But at least you do have the video that you can work with. Now, try to get those done, and remember, I will be here on November the 28th in the auditorium or the cafeteria, either one. So if you have a question and you're here and you need to see me in person, I'll help you on any of them. Otherwise, if you need some help with something, then send me an email, go through Populi, or you can take a picture and send it to me, or just ask me a question, I'll send you a picture back. Okay, So, quite a bit of work to do. But on chapter 11, you have a worksheet. And chapter 12, you have a worksheet. So those are easy. It was just that chapter 9 that's rough. Okay, thank you very much.